Hi, good day. This is a new series of my YouTubes. Some of you know my channel. I've been uploading several tutorials regarding engineering. Today's topic is a little bit different. We will try to talk about engineering economics. This will help the people, the new beginners in engineering economic field, and also will help them if they are preparing for certain tests or admitting tests like CCP or CCE. Okay, so the topic is being split into two parts, part 1 and part 2. I'm done with the first tutorial, which is the part 1, but part 2 still under preparation. So part 1 will be talking about 4 topics: definitions and overview, simple interest compounding interest rate, present value and future value. Topic 3, single payment, and all the formulas and the tables for all type of payments. Then topic 4 will be net present value, cash flow diagram, and alternative investments. Topic 2, for the time being, I split it also into 4 topics. Sorry, the part 2 I split into 4 topics, but it might have some changes. We will talk about annuity, uniform series, then gradient, which is inclined or declined series. Okay, then 7 we'll talk about depreciation, salvage value, tax. Then at the end we'll do some solve problems. Okay, let us start with topic 1, definitions. So what we are going to discuss in the definitions, we'll talk about the definition of economics, definition of economic analysis, the money value, the inflation, and escalation. Let us start directly. Definitions of economics. So what is the definition of economics? The general definition of economics is how to satisfy your unlimited needs or wants with your limited resources, or in another way, how to use your resources efficiently. So when you are using your resources efficiently to satisfy your unlimited needs, this is called economics. This is the just general, brief, simple definition of economics. Once again, it's how to satisfy your unlimited needs or wants with limited resources. Fine. So the second definition is economic analysis. What's the definition of economic analysis? Economic analysis is to compare between 2 or more scenarios. So let's say you have 2 or more investments and you want to do a comparison. So this is what we call it economic analysis. In this simple example, you can see here we have scenario A and scenario B. So let's say scenario A is investing in stock market, then scenario B is making a fixed deposit, just simple putting your money in a fixed deposit. So how can I compare between these two options, these two scenarios? I have to do the economic analysis. I have to put the two scenarios. I have to check what is the capital required for this scenario, what is the capital required for the second scenario, then what is the time to get your return, assuming T1, and what's the time also to get your return for scenario B. Then at the end, the amount of return, okay, from the first, from option A, and amount of return from option B. Usually, to have a proper comparison, you have to have the same time of return. So when you do a comparison between two options, scenario A and scenario B, you're going to get your amount of return and you're going to decide on your investment. You're going to decide if I'm going to scenario B or I'm going to scenario A. This study, and this is what we are going to try to explain in the next slides and in the next topic also, is called economic analysis. Okay, now we are on the third slide, I think. We're talking about, again, we're talking about the definitions before we start into the main core of the tutorial. What is the meaning of money? So we're going to talk about money, inflation, and escalation. What is the value of money? What is the value of money? And is the value of money constant? This is the most important question. Why money does not have the same value all over the time? So what is the value of money? Is the value of money constant? Is $5,000 has the same value always? What is the other dimension which goes inversely proportional to money? Okay, let us answer the first three questions. The value of money is the value of the commodity or the goods which you are buying. So is the money constant? For sure it's not constant. $5,000 does not have the same value always. So as a result, what goes inversely proportional to money? Time. If you look to this small diagram or snapshot, this is really a symbolic picture, but it explains what we are talking about. It explains that today, or let's say 50 years back, I can bring a house with this amount of money. With the same amount of money, I'm not going to bring the same house. I'm going to get a little bit smaller, smaller, and smaller. Okay, so can I ask you, what was the value of your house in 2000? Just roll back in memories and remember how much was the value of your house and how much today the value of the same house which you are living in. It's not the same. Why it's not the same? Let us see in the next slide. Why money value decreases? So always the money value is decreasing. What you can buy for $5,000, you cannot buy it tomorrow for the same item. So why money value is decreasing? Due to good price increasing. In another word, due to inflation. This is the basic term, inflation. Everything is inflating in price. So what is inflation? Inflation is the increase in price of several goods. Let us have a look on this table. I brought this table from the internet, which talks about several goods and items. I think it starts from 1890, yeah, 1890, and goes up to 2011. So those are the items and those are the prices. Fine. So just have a look. See. Let's take this example. 1910. What was the steak price? It was 17.4 cents. While today, not today even, it's even 2011. So in 2011, 4.69. Take the potato, 17 cent. What about today? 17 cent per 10 pounds. Today is $7.35 per 10 pounds. So just roughly, I did a small exercise, but this exercise does not reflect the actual inflation rate. It's just random figures. I said let us just give it a try. So I took I calculated the inflation of several goods through 101 years. So I took 1910 and 2011. Flour 15.5 times, so 1527%. Steak 26.95 times more. Milk 11 times more. Potato 43 times more. Okay, so if we're going to do a shopping today, what would be the cost difference? So I'm taking 2011 and doing shopping, and I'm comparing the same items to 1910. So just I picked randomly some figures as if I'm doing shopping. I went to the supermarket, I put some items in my basket, calculated everything. I got certain items for almost $2. The same items are $21.14, almost 11 times. Again, I'm telling this is just random exercise. It does not reflect the actual inflation. Okay, so in the previous slide and in the previous table, we saw that the money value is decreasing by years, and as a result the good value is increasing, and this is what we mean by inflation. Now let us read the proper definition of inflation. Inflation is the percentage of increase in general price level, general items, of goods and services in a certain economy or country over a period of time. The higher the inflation reflect a reduction in purchase power per unit of money. So when we have higher inflation, our purchase value will be always less. Inflation rate is measured yearly in the form of percentage. So every year the government will measure the inflation of its economy, and it's going to announce how much was the inflation rate. Usually 2%, 3%, depends country to country, but the country which has the higher inflation, the people of those country will suffer of difficulty in purchase power, or less power in purchasing the items. Let's see in the next slide. Okay, so what's the inflation basket? How usually they measure the inflation? There is something which they call it the inflation basket. Each company has the inflation basket different than the other, sorry, not company, country. Each country will have the inflation basket, which is not necessary to be similar to the other country. The inflation basket is a list of goods in a certain country which is used as a reference to monitor the percentage of increase of prices. So the total percentage of change reflect the inflation rate. They have a list of items, they'll go shopping, they'll get the total value of those items. Next year, the same items, they'll check the total value, then they will compare the difference and they will get the percentage. Okay, now another term, escalation. What's escalation and what is the difference between escalation and inflation? So escalation is defined as the change in cost or price of specific goods or service in a given economy over a certain period. So what's the difference? I don't know. Somebody could catch the difference. The difference is this: specific item, specific goods. So when we talk about inflation, we are talking about general economy. So all over the country several goods, but when we are talking about escalation, we're talking about a specific item. Example, steel. So steel is escalating up and down. Okay, sorry, it's fluctuating up and down. So escalation for steel might be 10%, 20%, depends on the year. So this is also a screenshot of hot roll steel price from Jan 2010 up to November 2011. So the difference between escalation and inflation, that inflation is general and escalation is for specific item. Okay, we are done with topic number one, which was the definitions and the overview. Now we're going to start with topic number two. It needs little bit more concentration, so you can pause and you can have a little bit break. Then we'll go through topic number two. So what is the structure of topic number two? We're going to talk about terms used in our analysis, simple interest, compounding interest, nominal and effective interest, present value and future value. So topic 2 will be split into 6 items. Let's see the next slide. Okay, so in this slide we're going just to present the terms. We are not going to go deeply inside each and every term. If you'd like, you can pause the screen and read everything properly, but now we're just going to go through the terms, and later on in the other slides we're going to use those terms and we're going to stop and explain each and every term. So the definitions are as per AACE International. P is going to present the present value, okay, so the money value now. F is going to talk about the future value of your money. G, I, small I, is the interest rate. Then K, number of compounding period per year. So if you are having a payment quarter annual, so the number of compounding per year is 4. K will be 4. Alpha, I think this is called alpha, I'm not sure, is defined as the effective interest rate, and we're going also to discuss what is the difference between the interest rate and the effective interest rate. Then N, the total number of compounding periods, okay, and also we're going to explain that properly. R is the nominal annual interest rate, so you might have effective interest rate, and then from effective interest rates you are going to get the annual interest rate. Then MARR is the minimum attractive rate of return. Your investment always has to be higher than the minimum attractive rate of return. B is the benefits and C is the costs. Okay, so now we're done with definitions. Let's go to calculation. I think now the topic will be more interesting when we're doing calculation. Okay, so we're going to calculate simple interest in the next slides, and then we are going to calculate compound interest and determine the future value and present value. Sorry for that, this should be number 2. Okay, next slide. Okay, simple interest. What is the simple interest formula? So simple interest is just a simple multiplication of interest rate into the number of years. There is no compounding effect. Simple example about that. If the investment is $10,000 and your interest rate is 10% per year, so at the end of year number 1, Y1, end of year 1, 10,000, let us just get the ball pen. So your 10,000 into the percent, you're going to get $1,000. Again, at end of also year number 2, where is the cursor? Here. Okay, so at the end of year number 2 also you're going to get again $1,000, which is 10,000 into 10%. There is no compounding effect. So 1,000 and 1,000, 2,000, the total capital after the end of investment is going to be 10,000 plus the first year plus the second year, as simple as that, 12,000. So your rate of return is 2,000 over the total investment 10,000 is going to be 20% per 2 years, not per year. So the interest rate same as the interest rate per year, which is 10%. This means your interest type is simple interest, no compounding effect. So in the next slide we're going to see the difference. Okay, now we're going to talk about the compounding interest equations. Again, we have the arrow here. Fine. Okay, so compounding interest equation. I'll just jump directly to the last paragraph, then we'll go up and we check all these terms. So if we are talking about the same investment, which is $10,000 in the previous slide show, over 2 years, what's the equation? Before was the equation, just let's go back to the previous. The equation was F equal P into I into N. N is the number of periods, I is the interest, P is the value of money, present value. Okay, in this equation the terms are a little bit different. Again, we have F, we have P, we have I is the interest rate, which interest rate is the nominal interest rate. Okay, into the power N. N is the number of periods. N is the number of periods. In this example, it's 2 years. Fine. So N is 2 years. I is 10%. Okay. And everything you can just put the numbers 10,000 into 1 plus 0.1. Again, you're not going to put the percent I, you're not going to put it as 10%, you're going to put it 0.1. So 0.1 plus 1 all into 2. Try it on your calculator. This will give you 1.21 into the value of your money, your investment, P. So you're going to get 12,001. What was the previous value? It was 12,000. So what happened? Now it increased to 12,100. So 12,100. What is the difference? The difference is 100. Why is the difference? This is because of the compounding effect. In another way, at the end of year 1, if we're just talking at the end of year 1, your investment going to be 10,000 into 1.1, so it's going to be 11,000. Again, as if I'm putting the 11,000 one more year, so your 11,000 into 10% is going to be 12.1, so 12.1 thousand. You are taking the interest occurred in the first year and you are going to add it to your investment and you are going to compound the amount. So I just cleared the screen to have more place to write. So you will ask why we didn't explain about this formula. We just solved the example assuming that I, the nominal interest rate, equal 10%. But how we got this? Why we got the interest rate equal to 10%? The interest rate, nominal interest rate, does not has to be uh, equal to the effective interest rate. Effective. Sorry for my handwriting again. Okay, so not necessarily equal to effective interest rate. Why in this example it's the same? Because the number of periods k is equal to 1. What does it mean? We are going to be paid once in the year. The bank is going to pay for us the interest once in a year. So let us just substitute 10 I equal 10%, which is the nominal interest rate. Why? Because I equal 1 plus r over k to the power k minus 1. This is again from the Skill and Knowledge 5th edition book. I equal 1 plus r over k into the power k minus 1. R over k also we refer to it by the effective interest rate per period. Okay, just substitute now. So 1 plus r over k, so k equal 1 as we said before, because the bank is going to pay for you 1, and r is going to be 10%, so 10%, because the interest rate is paid once at each year. So I equal 1 plus 10%, which is 0.1, into the power k, which is 1 minus 1. Just try it in the calculator. So whatever whenever we have into the power 1 means same. So 1 plus 1, 1 plus 0.1 minus 1 equal 0.1, which is 10%. So in this example, the nominal interest rate is equal to the effective interest rate, which is paid per year. Okay, in this example, not always necessary. We're going to see this in the next slide, and we're going to find the difference. Okay, so in this example, I think we're going to explain the difference between the nominal and the effective. Okay, example number 1. If a bank is charging you on your credit card 2.5% per month, you know, credit card in most of the world they charge per month. So what would be your total interest paid per year? Again, let us refer to this equation. Some of you will say 12 into 2.5%, which is 30%. This is wrong, totally wrong, because you're going to pay 2.5% per period, which is per month, and this is not the nominal interest rate. This is the effective. So per month is the effective interest rate is 2.5%, which is 0.025, sorry. And so this is the effective. This is alpha or phi, I don't know, again, phi. Why we didn't use r over k? Okay, let us roll back to the definitions and see what was r. R was the nominal annual interest rate. So do we need it? No, actually we are looking for the effective interest rate, which is per period. So if you have your interest rate, R per annum, you divide it by 12, then you get the effective. But in this example, the bank is telling you we are going to charge you 2.5% per month. Okay, so let's come back to the example. I, nominal interest rate, is equal to 1 plus phi into the power k minus 1. 1 plus 0.025, close the bracket, into the power k. K is 12 payments per year, because each month you are going to be charged 2.5%, minus 1. So I is going to be 0.3449, which is 34.49%. Try it on the calculator and you're going to get the same result. So this is not equal to 30%. Fine. Let's do another example. So in the other side, if the bank is giving you on fixed deposit 6% per year but paid quarter annually, so what would be your interest rate given per quarter annual? Some of you also going to say 6 divided by 4, because 6% they are going to pay me each 3 months one amount, which is 6 divided by 4 equal 1.5%. This is again wrong. Just let me change the color of the pointer. Okay, fine. Why? Always we have to substitute in the equation. So 6% is the nominal interest rate, because they are going to pay you 6%, but those 6% are divided into 4 quarters. So 6 equal 1 plus alpha into the power 4, because each 3 months one payment, so per year 4. So k equal to 4 payments, minus 1. So 6% you are going to substitute and take the 1 to this side. So 1 plus 6% equal to 1.06 equal 1 plus alpha into power 4. So all what I did, I just took the 1 to this side. Fine. So change the sign of the power. So take the power to this side. So 1 to the power, sorry, 1.06 to the power 1 over 4. So this is just mathematics. If you are just, as if I'm putting it under the radical of power 4. So 1.06 into the power 1 over 4 equal 1 plus alpha. Use the calculator. 1.06 to the power 1 over 4, or if you want 1.06 to the power 0.25 equals to 1.01467 equal 1 plus phi. Then phi equals to 0.01467, so it's 1.467%. This is the effective interest rate. So it's also not equal to 1.5. So actually, due to the compounding effect, they will tell you, the banks will tell you, we are going to pay you 6% at the end of the year. Your total amount is going to be 6%. But actually, per quarter annual, they are going just to give you 1.467. So for the rest of the slide shows, we are going to use only I nominal, which is the nominal interest rate. Whenever we say I, means nominal interest rate. We are not going to go into this details anymore. Okay, so present value and future value. So since we talked about all the previous concept of compounding and the inflation rate, so this is just a brainstorming which I like to share it with you. So as we agreed that money does not have the same value across the years, and this is due to inflation. So it's obviously, if you are investing in cash, you should have at least your minimum rate of return should be equal to just let me bring the cursor, equal to or greater to the inflation rate. Why? So if you are investing in the bank, your bank at least has to give you above the inflation rate to preserve your money, otherwise you are losing. How this happen? Okay, in another word, if the average inflation rate in your country is 5%, okay, and you have an investment which giving you, this is wrong, 5% as rate of return, then you are offsetting the inflation rate happening at your country. So whenever you are offsetting the inflation by the interest, means you are at least preserving your money. So at least you could preserve the money. Fine. But if you are getting less the inflation, apparently you are getting money, but actually you are losing. How? So if your bank is giving you 2.5% per year, apparently you are gaining, but actually you are losing due to inflation. Example, if you invested 1,000, after 1 year your bank will give you 2.5%, so you're going to get $1,025. But those of a present value, what about the future value? The future value of this 1,025, remove from it the inflation, which is the 5%, which we talked about it here. So divided on 105, so it's going to be 976. So your 1025 after 1 year are having a purchase power of $976, and this is explained in the previous slides when we showed the value of the goods and items along 101 years. So in the bank you will have this amount, but is this amount same the amount of 1,000 or $1,025 at the present? No, it's going to have a value of 976, which is F. So this is P and this is F. Since we're going to go deeply in several types of payment, as we said before, single payment, compound payment, uniform series, and so on. So it's really difficult always to use the formula, which is to convert P to F and convert F to P, and then the annuity and all this stuff. So there is something we call it the notations. Notations are nothing except pre-done formulas on several percentage of interest and several percentage of n years. Let me show you the example. Okay. So this is a compound interest table, okay, for several types of payments. So later on when we talk about F, so if we are finding F given P, so we're going to use this column. What we have to do, we have to open the book. There is something called the compound interest tables or book, whatever. You can also find it in the skill and knowledge course. And then you open on the interest rate, which is the nominal interest rate. Then you go and pick up the year N. Okay, so if you are finding F, you have to stop on this. If you are finding P, you have to stop on this column, as you saw here, single payments. Then if we are doing the uniform payment, and which we are going to explain later, we are going to use these notations. Then we are talking about the gradient, we are going to use these notations. So this for the uniform, this for the single, and this for the arithmetic. So it's very simple, and especially when you're going to go to this type of payments, which is the arithmetic, and the uniformity, which is the annuity, the formulas are going to be very long and very big, complex, I think I have it in the next slide. Let me see if I have it. No. So I prefer to have those tables and make the calculation easy. In the next slides also we're going to refer to the table. Don't take the issue complicated. Just simply when we are finding f, okay, and given p, so when we are finding the value of money in future, providing that the example has the value of money in the present, and we have the interest rate, and we have the number of years, what we're going to do, we're going to open the tables, pick up the n, sorry, the I first. So you'll browse in the pages, you'll find at top of each table, at top of each page the interest rate, then pick up n, okay, find the payment which you want, and pick up the column and catch the factor. Okay, simply, if you remember, we did the single payment finding f given p on 2 years. If you recall, 2 years single payment, okay, go down, finding f given p 1.21. If you remember, we did the $10,000, again sorry for my handwriting, into 1.21 equal $12,100. Do you remember? Let us roll back. Here, okay, finding f given p, finding the future value, giving the present value. Okay, so why we stopped on the tables? If you see here, the formulas really are very complex. So for the annuity, see how big is the formula. For the arithmetic payment, arithmetic gradient, see how big is the formula. You're not going to memorize such big formula. So simple, just go to the tables and pick up your factor. Okay. Okay, now we are ready to discuss topic 3. Let us have a break, and afterward we'll jump to topic number 3. We stopped before at the topic number 3, single payments. So now we are going to discuss more about single payments, and we are going to find the future value given the present value, or we can find also the present value given the future value. So topic number 3 is just about single payment, which is one payment. It's going to happen at the end of period, at the end, for example, 1 year, or the second year, or the third year. So it's a one-time payment, and it's not series of payments. So before also we wrote the equation of single payment, which is very simple. F equal P, open bracket, into the interest rate plus 1, close the bracket, into power n, and n is the number of periods. And also we showed before in the previous, just let us roll back, we showed before the different type of equations of different type of interest, and we said it's up to you how you want to use how you want to calculate. You're going to use the formulas, or you're going to do it using just the notation. I prefer to work with the notation, and the notation is it has to be written in a certain way. So now when we talk about the notations, same given and same required. We are going to find f given p. So how you write the notation? There is two methods to write the notation. If you cannot memorize always, I prefer to do it in this way. If you are finding f, okay, so for example you are finding f and it's given p, fine. So open a bracket. What you wrote first? You wrote f because you're finding f. So again write f over p, because what you wrote second is p. F then p. So write f over p, comma, n, sorry, I, comma, n. That's it. F given p, f over p, I, n. There is also some people use this simple method, which is p over p. So p over p, it will go, so you can cancel p with p, then remaining is f. So you're finding f. In the same way, if you are finding p, just write finding p given f, then you have to open the bracket, then write p over f, comma, I, comma, n. As we said, interest rate and n number of period. Roll back to the table. So this is the notation of p over f, which is you are finding p given f, and this is the notation of f over p, which is you're finding f given p. Now we are going to solve some examples based on the compound interest, and we're going to do it for 5 years. So we are having a single payment, compound interest single payment. Let's read the example first. A bank is giving an interest rate of 10% paid yearly on fixed deposit. What would be the total value of your investment at the end of the 5th year if you are depositing today $10,000? So what we have in this example, let us just pull back the pen and the color. Okay, so we have the interest rate, and it's been told that they are paying yearly, so it's a single payment each year, and we have the total amount, and we have the number of years, or n, which we call it n, the number of years or number of periods. In this example it's year. So what we need to calculate? We need to calculate the f given p. We are having the present value, and we want to get the future value. Present value is $10,000, and we want to calculate future value at the end of the 5th year. So we can do it in the both methods. Method number 1, formula as we did before, 10,000 into 1 plus I, 10%, close the bracket, into the power 5. 10,000 after calculating, so you're going to get 16,105. 16,105 dollars at the end of 5th year. The other way, which is the notation and the tables, as we said before, go to the tables and first pick the page which is having the required interest rate. In this example it's 10, so I got the page which is showing 10%. Then scroll down to the number of years, so here we have 5. Then pick up the correct notation. What you have? You have p. What are you going to find? F. So finding f, given P. You are finding the future value given the present value. So 1, 2, and 3. Draw a line and pick up the correct factor. 1.611. F equal 10,000 into 1.611. So what we got? We got 16,110. There is $5 difference. Why? Because you know this notations are rounding to the third decimal value. So on big amount you might find little bit of difference. Now this is an interesting example. Why? Let's read and see. So if we want to calculate now P, the present value giving the future value, we are going to also to use the notation or formulas. I prefer, as we said before, the notation. So let's read the example. Example says, considering that as a retirement plan, you need to have after 20 years a wealth of $1 million. So if you want to collect $1 million, okay, as a retirement plan for you after 20 years, neglecting the effect of inflation, what would be your investment today in national bonds which return 15% yearly? So what we know now? We know that 15% is the rate of return in national bonds, and we know that we need at the end of 20th year $1 million, and we know that it's a one single payment yearly, as it's mentioned here, yearly. So we want to find P. Solution: given F, we need to find P. I is 15 and equal 20. So we'll follow the table and we'll use the 15% notation, and let's see. This is also a snapshot of the 15%. So now we change a little bit. This is the 15% page. So as we said, number 1, pick up the correct page. Number 2, go down to the correct N, which is 20 years in this example. Then number 3, pick up your payment method. Single payment, yes, single payment. What's given? Given F. What you want to find? P. So this is the correct one. This is number 3. Let us substitute in the notation formula. So let us just pick up first the erase. Okay, back to the ball pen. Fine. So 1, 2, and 3. This is the correct factor. So the correct factor is 0.0611. Substitute, and what we got? We got this one. P equal to $61,100. Okay, this is a little bit a different way of calculation because it's an example which got two different values of interest rate. Okay, an investment returns 10% at the first 2 years and 15% at the third year. Calculate the total F value at the end of the third year of the investment. The investment is $8,000. So since it's a single payment with different interest rate, now you have to split it up. You have to find F at the second year and F at the third year. So same way, I put the two different tables. This is page 578 and this page 580. This talking about 10% and this talking about 15%. Now in the first one, we are calculating F, the future value of your $8,000 at the end of the second year, because the first 2 years you're getting 10%. Fine. So $8,000, pick up the right factor here, 2.11, sorry, 1.21, 1.21, substitute and get the amount. So at the end of the second year, your amount, your future value is $9,680. This is the value of the second year. Now what you're going to do, you're going to take this value and substitute in the next formula, because you are going to find F3, which is the future value of the third year. So now your P is this amount, which is the future value of the second year, is the present value of the start of the third year. Correct? So substitute 9,680, multiply into the factor which is from the second table, Now you don't do this mistake and you pick up 3 because this is the third year. No, because now the number of years just 1 year, because you are jumping from the second year to the third year. So n is 1. Okay, multiply into this rate, you're going to get the value of 11,132. 11,132. This is single payment, but with two different rate of interest. Now we are done with topic number 3. Let's go to topic number 4. What we are going to talk about, we are going to talk about net present value, and we are going to talk about the cash flow diagrams and alternative investment and comparisons. Net present value or net present wealth. We'll read the definition first, then we will talk about the formula, and I'll try to describe when I'm reading the definitions. A rule is stating that an investment should be accepted if its net present value is greater than 0. And I'm saying here equal or greater than 0, because if it's equal to 0 means it's satisfying the minimum attractive rate of return. So if it's greater than 0 and rejected otherwise. According to the theory of net present value or net present wealth, as we said, some references say wealth, some of them they mention as value. So when you are doing an investment, you have to take into consideration to check or calculate the net present value. Your net present value has to be greater than 0. Then you are going to have more wealth. This is what's mentioned. Participating in positive net present value project will increase the firm or the shareholder wealth. A common basis is needed when you are comparing alternatives, and this is, we talked about it in the start when we put the definitions. We said you might have scenario A and scenario B, then you have to have common basis to analyze both scenarios. Alternatives typically will have different cost, right? So because this investment A, the cost is M1, and they will have also for sure different benefits. So scenario A will have M1 and scenario B will have M2, which is the money spent, and they will have also benefit 1 and benefit 2 over the analysis of the period, right? So the net present value method provide the platform to resolve alternatives into equivalent present consequences. Now this is also important, which is here, when you're comparing alternative, always select the alternative having the highest net present value. Let us read now the equation. Net present value equals present wealth benefit minus present wealth cost. So net present wealth equal present value benefit minus present wealth cost. In another word, it's the benefit minus the cost at present. Cash flow diagrams. What's meant by cash flow diagrams? Cash flow diagram represent the cash in and out versus time. So this is the simple definition of cash flow diagram. It's a representation of your cash in and out. This is out and this is in. We're going to explain more, but let us continue reading. It's a simple presentation of the flow in and out from the money during the period of investment. What does it have? It has two major parts. Number one is the horizontal line, which is the time, and number two is the vertical arrows, which is the cash flow. So let us just see this one. Let me just clear it a little bit. Okay, so this is the horizontal line, which is describe the time, and those are the vertical lines. Cash out is negative, which is down, and cash in is positive, which is up. This is the last title before we do some exercises. Then we will close topic number 4, and with this we will close also the first part of my presentation. So this title talks about alternative investments, and sometimes I like to call it alternative opportunity. What we mean by this: usually when you are going to do an investment, you should at least compare it with one alternative. You might say to me, but I don't have any other alternatives. So simply you can just compare it to your minimum rate of return. So minimum attractive rate of return. What is the minimum attractive rate of return? You can say, fine, if I'm going with this investment A, okay, I still have another alternative, which is putting the money in the bank. If I put the money in the bank, I'm going to get 3%. So even if you don't have except one investment, at least you can fix your minimum attractive rate of return and calculate your net present value, which is here, net present value. So obviously, if your net present value based on this minimum attractive rate of return is greater than 0, that means your investment going to provide you more than the minimum rate of return. The higher the net present value, the higher the returns. So whenever we're doing investment, we have to put the alternatives. Putting the alternatives is a solution, or it's a method to compare, or it's a platform to compare what is going to happen, or what's the return I'm going to get from my investment. This is the last example in part 1, and it's about net present value. Before we go to the example, let us just put the basic rules which we have to focus always on before we start any example. Again, the net present value or the net present wealth is PWB minus PWC, present wealth benefit minus present wealth cost. The greater the net present value, the better is your investment. So this is rule number 2. In case you don't have alternatives, just fix your minimum rate of return. Assume your minimum attractive rate of return and solve your example. Now let's read the example and see what we can do. A 2 years investment of $13,500 is going to return back to you $7,000 at the end of the first year and $8,000 at the end of the second year. So this is an investment. Today you're going to give 13,500 and you're going to get the first year 7 and the second year 8,000 for sure. So if you were my finance advisor, do you recommend me to go ahead with this investment? Yes or no? This is the question. Now you can do something. You can pause this video, solve the example, come to a result or to a recommendation. Then afterward, continue the video and see how we will solve this example. Now I'm solving the example. First of all, the best thing is to just have your cash flow diagram. So on the cash flow diagram, put your in and out. This is the out. This is the P at time 0, which is the PWC, present value of the cost you're going to pay, 13,500, and this is the line of time, and you're going to get this value of money at the first year and this value of money at the second year. Apparently you are paying 13,000 but you are getting 15,000, but as we said before, you cannot do it this way, and those values are future. So what you have to do, you have to bring them to present, because the equation says net present wealth equal to present wealth benefit minus cost. So those are the benefit, but they are in the future. You have to bring them to present. So this becomes P. And this is the value of present wealth cost, which is already in present. Now how to solve this example, and we didn't put the minimum rate of return. So to solve such question, you have to have another alternative to compare to, or compare it to your minimum rate of return, which can be the percentage of interest at any fixed deposit. Now I'm assuming in this example that the minimum rate of return is 10%. So let us now calculate P1 equal F1, open the brackets, write the notation as we said. Given F, you want to find P. This is the first F, F1. So given F, you find P, write the notation, and 10% is the MARR, minimum attractive rate of return. The first N is 1 year. P equals 7,000 into the notation this is the factor, 0.909. So we're going to get P1 6,363. What does it mean? This 7,000 is after 1 year, but this 7,000, if you take it to present, this 6,363. So 6363. What about the other values? F at the second year. So this return 8,000 has to be also brought to present. Write the notation P2. So we are finding P2 given F2 8,000. Open the bracket, write the notation, and now 2 years, because you are jumping 2 years backward. Okay, so you're going backward in time 2 years. This 8,000 at that time does not reflect the 8,000 value today. So P equal 8,000 into again the factor. So as you see here, there is difference between first year and second year. The more you go in future, the less the factor. We got 6,611.22. Now let's add the values. So as we said, 6,036 and 6,363 and 6,611.2. The total value So this is the total value of all our figures. We brought this here and we brought this value also to present. The total present value P1 plus P2 equal 12,974.2. This is the total present value. So this is the PWB and this is the PWC. Substitute in the formula net present wealth equal PWB minus PWC. 12,974.2 minus 13,500 minus 525.84 negative. What does it mean? What does this result means? So what's your recommendation? We got negative. As we said before, negative means it's not going to satisfy your minimum rate of return, minimum attractive rate of return. So it means that your investment does not satisfy the minimum attractive rate of return, MARR. So to solve the above, if you want, you can solve the above example and base it on 5% and see what will happen. Also, you can pause, do it on 5%, then come back to the video. Now we solved the previous example based on 5%. Let's say my rate of return is 5%. So substitute, everything is same, just what you're going to get, the PWB, okay, the benefits, okay, because the cost is same. So solve the same example, apply 5% and check what's going to happen. You're going to get positive 422.9 positive. So what does it mean? This means your investment is satisfying the minimum attractive rate and return and it's given even more. If you want to calculate the actual rate of return, because here we are putting 5% and we're checking if we are satisfying this 5% or no, but what's the actual? The actual, it should be more than 5%, because when we did 10% we failed, we got negative, and when we did 5% it came positive. So your value is somewhere here. How much somewhere here? This need trial and error. So you can do your trial and error until you get the approximate value. I did it and I found it's approximate 7.15. So this investment, if you pay 13.5 today and you get at the first year 7 and you get at the second year 8, as if you are gaining a 7.15% rate of return. That's it. Now we finished, we are done with part 1. I'll try my best to do part 2 as soon as possible. Hopefully you enjoyed the tutorial and you got benefits from this presentation. Let me see your comment. If you have anything to share it, just write to me, and you also can like my video if you found it beneficial. Thanks a lot.